In this video we look at how to get information about a function from a graph. You can see on this picture here that we have a function that goes from here to here. So if you think about what all the possible x values would be, the x values go from here across to here. So on the x-axis that's from here across to here. So the domain is in blue down here. It's all the possible x values from where the function starts on the left to where the function ends up on the right. And the range has to be from the lowest point up to the highest point. So it's this red part here on the y-axis. The range is all the possible y values. Now in pre-calculus and also more so in calculus itself, we talk about increasing and decreasing functions because it's quite a useful thing to be able to know if a function is going up or whether it's going down or whether it's actually kind of level, if you like. And you always have to think of going from the left to the right. And so imagine you're going up a mountain that starts here and you're going to end up way over on the right. So to start off with, you're going up, so the function is increasing on this green part here. And then you get to the top of a hill and you start to go down. The function is decreasing until you get to a valley bottom. At this valley bottom, you begin to go up again. You go up, you kind of level off a little bit there, and then you increase over here. So the function here is increasing here, decreasing here, and increasing here. Now, in terms of formal mathematical definitions, it means that if you have two x coordinates on an interval, x2 and x1, and x1 is just before x2, it means that the function value of x1 should be less than the function value at x2, because the function is going up to the right. Right? So the x value, if the x value is less than of the first point is less than the x value of the second point, then the y value of the first point should be less than the y value of the second. Okay, so that's a formal definition, but don't worry too much about that if you understand the picture. Now, it's possible to figure out the intervals on which a function is increasing or decreasing from a graph, especially if you have a graphing display calculator. That's what that GDC stands for here, a graphics display calculator, like your TI-84 or TI-83s. So what you can do on your calculator is enter, if you press y equals on the top left of your calculator, you'll see a window like this pop up, and you can enter an equation, y1 equals 2x cubed minus 2x squared minus 7. And here we've edited the window a little bit. You press window and something like this should pop up. The x min being equal to negative 2 corresponds to a negative 2 over here on the graph. X max of 5 corresponds to a 5 over here. You can see that it's 1, 2, 3, 4, 5 over there. And the x scale is 1. You can probably imagine that the y min being negative 20, the y min negative 20 is way down here. Y max equal to 10 is up here. And a y scale of 1 means that each of these little markers here is 1. So there are 20 of these little marks going down the axis. Okay, so if you graph that, you should get something that looks like this graph here. It's possible to press the trace button. And I wouldn't recommend the trace button in general, but it gives you an idea in a situation like this. If you press the trace button, you can then press the right arrows or the left arrows to move the cursor around. And so the cursor is this kind of cross here, and you'll be able to move that around, and you'll be able to see approximately what the x and the y coordinate of the cursor is. So you can move that cursor way up to the top. And if you do move it all the way up to the top, you begin to see what the coordinates of the point are, or at least you can give a good guess for those coordinates. So if you do that, you should be able to see the maximum there. The maximum occurs when x is equal to 0. So that means that this function is increasing, it's increasing on the interval from negative infinity up to 0, from negative infinity up to 0. Now, from here down to whatever the minimum is down here, whatever the x value is over here, it's probably 1, 2, 3, you can see. So we would the interval in which it's decreasing is from 0 across to 3. And then it increases again from 3 onwards, so we can say then that another interval that it increases on is from 3 up to infinity, right? From 3 up to infinity. Quite often in calculus, when you go on to do calculus later, perhaps at college, you'll find that people are quite interested in finding maximums and minimums because if, for example, you have a function that models the cost of something, you want to minimize the cost of something. Or if you have a function that models the profits that you're making, you might want to see if you can make a maximum maximum amount of profit. Okay, so we're interested in minimums and maximums, or what we should say is minima and maxima, because those are the Latin plurals. So we have things that we define that are called local maximums and local minimums, because in a function like this one here, this function might go on somewhere else to actually be bigger than these points here. The y value might get bigger than that somewhere over here. But as far as just being in this kind of area is concerned, in this locality, if you like, this point here is the local maximum. Right, there might be other maximums somewhere else, but really this point here thinks it's the king. And this point here also thinks it's the king. It's the biggest in that neighborhood, in that locality. So if you think about an interval around that point, it's the biggest y value in that interval. And that's kind of the definition of a local maximum. If you have an interval and you have a function that's the maximum in that interval, then it's called a local maximum. Now it's possible using your graphing calculator to again find the local maxima and minima. You can put your equation, an equation like this, press y equals and then enter an equation that looks like that. You then press graph, you get something that looks like this, and then you can use your trace button to find a point that's at the top and a point that's at the bottom. However, you only get it approximately. See this, we have a cursor here that's using the trace button to get there, but that's not quite at the top, and so we've only got an approximation here of the coordinates of the maximum point. If you wanted, you could zoom in a little bit. You can do the zoom box option, which draws a little box around this area here, so that it looks like this, and you can get it a little bit more accurate, using trace, and you can begin to see what the x value and the y value should be. You can probably guess that the maximum there is the point 1, 6, and the minimum here is the point 3, 2. So we can fill in the gaps in your worksheet using that. The local maximum occurs at 1, 6, and the local minimum occurs at 3, 2. The maximum value of the function is the y value, right, at the maximum, so that is 6, and it occurs when x is equal to 1. And if someone asks you what the minimum value of a function is, it's the y coordinate. So if you think about this point here, the y value is the function minimum, so you'd have to press you'd have to write down 2 for y, and it occurs when x is equal to 3. So on a calculator you would put the function into y equals, press graph, and you would get a graph like we just saw. If you want to get a closer look at the graph, what we can do is we can choose zoom standard number 6. You can press the down arrows or you can press 6 to choose it. Zoom standard gives you a window that goes from -10 across to 10. But you might want to zoom in a little closer. You can do that by using zoom box. Z box right there at the top, number 1. And what you can then do, you move the cursor so that it's at the bottom left of a box. Right, so this, where the cursor is going, is the bottom left of the box. You press enter, and then you move the cursor to the top right of where you want a box to be. You can see this rectangle being drawn so that we can have a closer look at the points on that graph that we want. This is just changing the window values. And when we get up here, so we've drawn it, we press enter. And so it zooms in as we want it. Then if we want to find the maximum point, that point right here, we'd press second, then calc, that's the trace button, but it's the second calc. And you then move the cursor, you get this window here, and then you move down. We want to find that maximum point there, so we press number 4, or we scroll down to choose number 4. Okay, so we're going to choose a maximum here. You need, when it says left bound, you need to be to the left of the maximum. So notice we're moving the cursor to the left of the maximum now. You then press enter. Then you move the cursor over to the right of the maximum, because it's asking for the right bound this time. So move the cursor over to the right, and then again press enter. And then it asks for a guess, so you just put the cursor somewhere near the maximum. It doesn't have to be exact. Press enter. And it gives you pretty close, very, very close to the maximum. It's a tiny little arithmetic error from the calculator, but really you can see now that the maximum is at 1/6. If you want to find a minimum, it's very, very similar. You press 3 instead of 4. Again, you move the cursor to the left of the minimum, where the minimum that we're looking for is right at the bottom here. So we may have to then shift the cursor over to the right of the minimum, press enter, and then go over the minimum and guess again, press enter, and again it should give us an answer that's pretty close to the coordinates of that point.